Everybody, and welcome to today's webinar. So good morning, good afternoon, or good evening, depending on where you are in the world today. Just a couple of introductions. My name's Michael Francis. I look after some of the marketing here at MediaTek Labs. And today's presenter is Philip Handschin, who's a technical consultant at MediaTek Labs as well. So, with no further ado, I shall now pass over to Phil, who's going to talk us through the new MediaTek LinkIt platform for RTOS.
Thank you, Michael, and very warm welcome to everybody online. As Michael already mentioned, today I'm going to talk about the new MediaTek LinkIt Development Platform for RTOS. RTOS stands for Real-Time Operating System, but I'm sure most of you are aware of this. So, what am I going to talk about today? First, I will give a quick introduction. What are we doing here at the MediaTek Labs? What is it all about? Then I'll have an introduction into the LinkIt Development Platform for RTOS. Then I will talk about our new SDK for RTOS products. And then the key facts about our first LinkIt HDK for RTOS, so that's the LinkIt MT7687 HDK. And then I'm going to talk about the software tools that are available for this latest platform. And as Michael mentioned, at the end, we will read out all the questions and I will try to answer them. So first, what is MediaTek Labs? It's a developer program. It's a global program. We have people all over the world who want to help you kind of create your idea, create your own IoT device. We have forums, we have HDKs, we have various different things where we can help you create your idea. So that's our whole ethos, is to go from idea to prototype to product. So you have to have the idea yourself, but with all the rest, we can help you. So we have, as I said already, HDKs, so hardware development kits where you can purchase. And then we have free SDKs available on our website. We have loads of documentations. We have a very active forum where our technical consultant helps you to answer all your questions. We have a lot of example codes. Basically everything you need to get started and to create a prototype. And once you have your prototype and you're happy with it and you're thinking of putting it into production or do maybe a prototype run, then we also can help you kind of finding the right partners for manufacturing, even for mass manufacturing, or if you need sensors or different third-party products, we can also recommend partners we worked with in the past. So please don't hesitate to get in touch. Best thing is to register on labs.mediatek.com and just start browsing around with our different offerings. Talking of our different offerings, we already have 4, so we now add the 5th to today. So we have the LinkIt One, our the board we kind of featured the longest already. It's very good because it has a lot of different connectivity, so it features Wi-Fi, Bluetooth LE, GPS, and 2G connectivity. Then the LinkIt Assist is basically the same functionality, just smaller and with a touch screen. The LinkIt Connect is a very low-cost and simple Wi-Fi board. And then we have the very smart LinkIt Smart 7688, which runs a Linux system on the system on chip itself. So it's an OpenWT Linux, and you can program it with Python, Node.js, or Arduino. And you can also do you can change the Linux system itself with C. So a very capable board as well. We have a huge developer community which are creating amazing projects all over the world, from really practical ones to really funny ones. So it's definitely worth checking out all these projects, basically on Hackster.io or on Instructables. Right. So enough talk about MediaTek Labs. So let's have a look at the LinkIt Development Platform for RTOS. So we have like 4 pillars. So the first one are our SoCs. They were announced earlier this year. So we will start with the MT7687F, which is a secure Wi-Fi chip, very low power. It's based on ARM Cortex-M4 architecture. Very, very smart SoC. Next thing is the real-time operating system and the APIs. So we chose to use FreeRTOS. I will go into details why we chose FreeRTOS in a bit. And we obviously have very easy-to-use APIs, so you can program your projects very easily. Then the next thing is our SDK and tools. So we have a GCC compiler for Linux, absolutely free. We have also support for Keel Microvision, and we have flashing tools to kind of flash the boards with your latest firmware, and we have a PinMox tool as well. I will go into those later as well. And obviously the HDKs, they will be available later this month. It's based on the 7687, and the modules we're using on that board are actually ready for manufacturing. So if you create your prototype with our HDKs, it will be then a very easy step to go into manufacturing. So what sort of applications do we see people creating with the 7687 HDK? We're looking at home appliances like aircon units or heating systems where you connect your aircon to your local Wi-Fi through the 7687 and then make it cloud enabled so you can control it with your smartphone. We're also looking at smart gadgets like power plugs, hoovers, like light bulbs, just anything around the house you can make smarter. Again, you will connect that then to your local Wi-Fi router, and then you can control it through the cloud with your smartphone. These are the sort of applications we can see being realized with this HDK. So let's have a look at the software development kit that comes. It's our third. So the first one was for the LinkIt 1. The second one was for the LinkIt Assist 2502. So now we have the third one, which is for the RTOS platform. And the nice thing about it is that the same SDK will work for different SoCs. So as I said already, like we will start off with the 7687, but we will add other system on chips later on. But they will work with the same SDK. So even if you choose to kind of, use a different SOC, you will be able to kind of use exactly the same environment to develop your application. The operating system is based on FreeRTOS. And we'll talk about that later. And it already includes a lot of packages, which makes it very easy to develop, especially some network functionality. So FreeRTOS, it's basically the market-leading real-time operating system. It's the de facto standard solution for microcontrollers, and it has like 2 key advantages. First of all, it's free, and second of all, it's supported. So it is open source, which means that like people are working on it on a daily basis and improve it on a daily basis. And it is already used in a lot of commercial products. So it's definitely, it's definitely a contender for commercial products. So that's why we kind of, for all of these reasons, we kind of chose to use FreeRTOS. Let's have a look at the architecture for the new SDK. So at the bottom, we have the drivers for the hardware abstraction layer. So we have analog digital converters, we have I2S, I2C, SPI, the real-time clock, GPIO, UART, flash. We have a security engine, pulse width modulation, and we also have infrared support, but I will go into that a bit in more detail. Then we have the middle where it's all about the network connectivity. We have XML and JSON support, like that I was talking about with the packages we already installed on FreeRTOS. So basically parsers for these files. And then on top we have the applications. So we have we can have it in access point mode, the Wi-Fi, or you have it in station mode. We have something called Smart Connection, which makes it easy to set up your IoT device. And we have a DHCP client and server. So this is the architecture. So let's have a look at the features. So if you put it in station mode, what kind of features do you have? So you have the standard 802.11 BGN station. We have all 13 channels, and we have some personal security, like VP Open, WPA, WPA2, but we have no enterprise security. In access point mode, it's very similar, again, like channels 1 to 13. We have personal security, and we support up to 9 stations at the same time. Like stations being connected to the 7687 as an access point. In the network features, we have we support IP version 4, TCP, UDP, ICMP, DHCP client and server. So depending if you're in station mode or like access point mode. Netcon and sockets. We also have the simple network time protocol. We support HTTP, like HTTPS based on SSL TLS. We use the embed TLS, and we can use it as client and server. And we also support MQTT. This is a lightweight messaging protocol, ideally used in IoT devices where you should keep the network traffic to a minimum. You saw like the smart connection mentioning before, so I just wanted to go into a bit more details. So this is MediaTek's way of kind of setting up like a device to make it very easy. So it's basically an SDK for both for like our RTOS platform, but also for Android devices, which means with your smartphone you can write an app that you can then set up your IoT device. So you would go into your app and you would enter like the SSID and the password of the Wi-Fi network you want the device to connect to, and then you can press a button and it will broadcast this SSID and the password, and the devices around like the 7687 will be able to pick that up securely and set it up for the device itself, and then from then on connect directly to the Wi-Fi network, and basically you can establish the connection in this way. So you don't need to have any buttons on the device or display where a user can set up the SSID and password. So it's a very easy and smooth way of setting up devices, and that is also included in the SDK. Some of the interface functions, GPIO, basically to control your GPIOs and update the PINMUX settings to apply functions to pins. INT, like set a callback function and receive alerts from external interrupts. PWM is basically you output the pulse width modulation signal with various different frequencies and duty cycles. Then the analog digital converter converts analog input, mostly voltage, to a digital signal. UART, basically you can read or write to a UART interface. SPI, read and write again to an SPI interface like a master or a slave device. I2C, read-write data through the I2C interface. to a slave device, then read-write data through the I2S interface to an I2S device. And last but not least, we have the infrared support as well, so you can send and receive through infrared. We have timers. We have the general purpose timer, which just provides a callback after a certain time, which is quite handy. We have the real-time clock, which keeps track of the current time in sleep mode and provides an alarm callback as well. And then we have the watchdog timers, which is a very useful tool to detect and recover from system malfunction. So if anything goes wrong, they can just check if everything's all right and necessarily kind of take necessary steps to get the system back up and running. We also have an encryption functions. We support AES, DES, MD5, and SHA. So on the chip itself, we have actually a secure engine to kind of like support these features, like a security engine. So this is just kind of like a brief introduction into like the SDK and our APIs. So please kind of follow these two links to kind of get more information about our APIs, or just go to labs.mediatek.com and find the RTOS platform. There you find a lot of documentation and API references as well. Right, so let's talk about the first HDK we will bring out. So some key facts about the LinkIt 7687 HDK. This HDK should be available in a few weeks' time, so please keep checking our website. We will announce it as soon as possible. So first, let's have a look at the 7687 system on chip. So it's an ARM Cortex-M4 based MCU with a clock frequency of 192 megahertz. It's a 1x1 802.11 BGN Wi-Fi, which is designed for very power efficient and robust connectivity. We have lots of different peripheral connectivity, as you could have guessed from the SDK. We have UART, I2C, SPI, I2S, PWN, and also infrared and auxiliary analog digital converter. You see on the right there like a rough schematic. We also have like a 2 megabyte of flash. We have 352 kilobyte of RAM, 64 kilobyte of ROM, and 4 kilobit of eFuse storage. And we have the integrated security engine, which is quite nice. And the whole chip is 8 by 8 millimeter with 68 pins, so it's very small indeed. So the HDK, some highlights. It's high integration, like with RF, MCU, and memory. We also support power consumption measurements. So while you are kind of creating your prototype or testing your proof of concept, you can actually very easily measure the power consumption of the board and of your application, which makes it very good for then, optimization. Maybe you have to optimize your code or kind of the usage of the hardware. The board will be able to be powered by 2 AA batteries. So you see it is a very power efficient board. We have an integrated 4 kilobit eFuse to store device specific information like RF calibration data. And we have a very low power mode with a real-time clock. On the board as well, we have the security engine, which helps to kind of encrypt the data connectivity, which obviously is like a hot topic in the IoT at the moment. We have to make everything very secure. And we have infrared control, so you can send and receive via infrared. And the module we will use on the board is ready for mass production. So everything you do on that board can be then later translated into your product. And again, secure communication through TLS. Right. So let's see what kind of software you could use to kind of program your HDK to create your project. We have two options for development. The first is ARM. We have a plugin for the ARM Keel Microvision IDE. We are aware that like not everybody uses this IDE, so we also offer like a free command line tool chain. This includes a GCC compiler for Linux, where you can compile your projects, a flash tool for Windows to flash the firmware to the latest one, and we also have like an easy pinbox tool to kind of define pins and their functions. But we also have like loads of example projects where you can get up and running very quickly and understand like the different features of the board. And we also have a lot of documentation, like a getting started guide. And for each of the tools, we have like a separate kind of document where you can read. So we have a very extensive documentation. Also, the API reference guide is very well documented and available online. So it's definitely worth having a look on labs.mediatek.com to check out all the documentation and all the tools available. Right, as Michael said at the beginning, now I think it's time for answering some questions. I hope I will be able to answer them. So let's have a look.
Thanks, Phil. That was really interesting. So we have some questions regarding the availability of the HDK from VJ. The latest is it should be mid to end April, but we'll keep you up to date on that one. And we have another question as well from VJ, who's asking, will we support Linux on this chip later? So I think that's one for you, Phil.
Right. As it is like a real-time operating system, we won't. Like we went with FreeRTOS, and we will stick with FreeRTOS in this case.
Thanks, Phil. We have another question from Ashwani, who's asking, what is the size of the SRAM on the 7687 SoC?
That's a very detailed question. I will have to get back to you on this one. So if you could send me an email with your question or post it in the forum, actually, that would be the best, because then I will pick it up and answer your question.
Great, thanks, Phil. And so we have another question: is can the flash be expanded by external chips?
Yes, that would be possible, but that obviously that will be then going into mass production. But that will be possible.
Thanks, Phil. Another question from Ashwani is: are there debugging facilities in the SDK?
Yes, there are. I didn't go into too much details about the debugging, because we will have, once the HDK is out, we will have another webinar, like Michael will schedule it and inform you all by email, and we will then go into details about all the tools and how to use them, including debugging. So they are specific debugging tools, yes.
Thank you, Phil. And another question from Rai Vilo is asking, do we have any date for FreeRTOS support for previous LinkIt boards?
Previous LinkIt boards, I think we won't support FreeRTOS on previous LinkIt boards. They will stay on their software, so the LinkIt 1 will stay on the Nucleus-based LinkIt operating system, and then the 7688 is kind of based on OpenWRT. So we won't change them to FreeRTOS, I'm afraid.